All right, AC, CC, or D. So what I'm going to do is I'm going to do AST first. I'm going to see if it converges by AST. Does it look like these positive terms would be getting smaller as n's are getting larger? It looks like I've got more in the denominator with this n cubed and n squared as n getting larger. So yes, I would say terms look like they're decreasing. Let's check out this limit. N squared plus n minus 1, n cubed plus n squared minus 1. Okay, so it's necessary to write this thing down in its great glory, all of it, then go use the highest powers. So limit as n goes to infinity of 1 over n. N's going to infinity, so I get 0. So what do I have? I've got that this thing, so it's necessary to write the whole thing out. Lots of writing, I know. Converges by AST, right? So it converges by AST with the negative sign. So then what our job is to do is to go check to see what the positive part does. So the positive part, this takes us back to reminding ourselves, this is a too much going on situation, so I want to go right to an LCT with a new sum. And remember, the new sum I make up with the highest powers. So I'm making up a new sum, and it turns out to be 1 over n, which I know diverges by the p-test. So now I'm ready to do the limit comparison test. So I'm going to write down the original guy and multiply by the reciprocal of my new sum. So now I'm going to take highest powers, so I get n cubed from the numerator, right? And I get n cubed on the denominator. So that's 1. Since that's bigger than 0 and not infinity, they both do the same thing. So I get the conclusion. So it's necessary to write this out. It's a lot of writing, I know, but you're writing out an argument. This diverges also by LCT. Okay, so I have the positive part converging by AST, and I have the whole thing converging by AST, and I have the positive part diverging by limit comparison test. So the final conclusion, the therefore, it's necessary to write the whole thing down again, because you want to say the original problem is CC. This is the only way you get conditionally conversion. Converge by AST for the whole thing with the negative, and when you check the absolute value, that you find out it diverges by some test. Therefore, CC. Okay, let's try this one. So again, I'm going to start with AST. You don't have to do this. I'm just showing different ways you could go about it. Does it look like the terms are decreasing as I plug in bigger n's? Yes, this looks like it's got more in the denominator. What happens when I take the limit as n goes to infinity? Get limit as n goes to infinity, 2 to the n over 3 to the n. Good old limit things again, 2/3 to the nth power, that number k, remember that k limit? Since that number is less than 1, this limit is 0. Okay, so what I get is therefore this converges by AST. So it's necessary to write this and to say the test name. Okay, so now I'm going to go check to see what the positive part does. All right, I'm thinking it's looking like a basic comparison test because it seems like it'd be easy to pull off one number. So this has more on the denominator, so this is smaller. So this would give me 2/3 to the n. So what do I know about the sum of 2/3 to the n? That's a convergent geometric sum, right? Is that good? Oh, bummer. BCT is a bust because this is the smaller sum, right? This is the smaller sum. Basic comparison doesn't work. So off to limit comparison test. Limit as n goes to infinity. I'm going to write the original guy, multiply by the reciprocal of my new one, this one. So if I take the highest powers, I'd get 2 to the n, 3 to the n, 3 to the n, 2 to the n, right? Because I'm just taking highest power, so this little 2 here goes fades off in the distance. These cancel to get 1. That's bigger than 0, and it's not infinity, so therefore I get this converges also by limit comparison test. Okay, so this converges, positive part converges, and it converges by AST. So my big therefore is that this one is absolutely convergent.